Let's continue looking at examples of degenerate conics to see what other situations we can find ourselves in. Sketch a graph of 4x squared plus y squared minus 8x plus 2y plus 6 equals 0. Let's rearrange the terms of this equation so that the x's and y's are together on the left, then so that the constant term is alone on the right. So if we move the constant to the right, we've got to subtract 6 from both sides, so that gives us negative 6 on the right. We're also going to have to factor out the 4 in front of the x squared, so this becomes 4 times x squared minus 2x, and then plus y squared plus 2y. And now we can complete the squares. To complete the squares with the x's, we need to add 1, but what we're really doing is we're adding 4 times 1, which is 4, so we need to add 4 to the other side of the equation to balance it. And then to complete the square with the y terms, we need to add 1, so we need to, of course, add 1 to the right-hand side. And so when we do this, we can factor out those perfect square trinomials. So we get 4 times the quantity x minus 1 squared plus the quantity y plus 1 squared on the left. And on the right, negative 6 plus 4 plus 1 gives us negative 1. So this looks sort of like an ellipse because we've got x squared and y squared terms on the same side, but with different coefficients. They've got the same sign, but then on the other side, we've got negative 1. And we know that we need this sum of squares to be positive 1 if it's an actual ellipse. We can't make it that way because if we want to make this a positive 1, we've got to divide by negative 1, and then we've got a bunch of negatives on the left. So this is a degenerate ellipse, doesn't quite work out. And if we try to graph it, we notice there's not going to be any graph because this actually has no solution. We know that when we've got a perfect square quantity, that's got to be non-negative. It's got to either be positive or 0. And we can't take two quantities that are positive or 0 and add them together and end up with a negative. So in this case, there's no solution, and of course, then our graph would be nothing. There is no graph. It's an empty graph. So this is another example of a degenerate conic. In fact, this is a degenerate ellipse, and because we've got a sum of squares equaling a negative number, there's no solution, and so there is no graph in this situation. So we saw one example where we had 2 lines. We've got another example now where there's no graph. Let's look at a third example to see what else can happen. Sketch a graph of x squared plus y squared plus 6x minus 4y plus 13 equals 0. We'll go through the completing the squares process here, just as we have in the other problems. We'll start by grouping the x terms together, and then the y terms. And we'll move the constant to the other side, which will turn it into a negative 13. Now there's no leading coefficients that need factored out, so we can just go and complete the squares. To complete the square with the x terms, we've got to add 9, so we're going to have to add 9 to the other side as well. For the y terms, we've got to add 4, so we're going to add 4 to the right-hand side. Now when we factor this out, we get x plus 3 quantity squared plus y minus 2 quantity squared on the left. And on the right, negative 13 plus 9 plus 4 actually gives us 0. And so this is actually a degenerate circle. It's basically a circle with radius 0. So the center is going to be at negative 3, 2. So that's to the left 3 and then up 2. And if the radius is 0, well, the only point that's 0 units away from this is that point itself. And so in this case, our graph is just 1 point. So there are 3 possibilities that we've seen here that we can end up with. We can either have 2 lines, we can have no graph at all, an empty graph, or we can end up with 1 point. And the option that we end up with really depends on the particular situation. So whenever you're looking at one of these, you've got to go through and think, is there going to be no solution? Or is this something with a radius 0? Or is there something where we've got to use the square root property and the plus or minus gives us 2 lines? There's different scenarios, and with practice, you'll be able to see which scenario you're in each situation.